Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of Kubernetes Troubleshooting Zero to Hero series, and in this video we will learn about one of the most common Kubernetes pod status, that is crash loop backoff. So if your pod is not in the running state and if there is some issue with the application, container or your pod, most likely the pod status that you would see is crash loop backoff. And crash loop backoff does not occur for a single reason. There are multiple reasons why your pod can actually go into the crash loop backoff status. And in this video, we will cover the 3 top reasons why your pod can go into crash loop backoff status. These reasons are most commonly faced by DevOps engineers in their real time and also asked by the interviewers during the Kubernetes interview section. So please try to watch this video till the end. And after watching, you can practice the same things. You can revise the material and implement using this simple Python application. Now, before we start this video, I have a very important announcement to make. GeeksforGeeks is running a 390 challenge. That means before 30th of April, that is before the end of this month, if you buy any of their courses and complete the course within the 90 days from the date of your purchase, GeeksforGeeks is going to give you a 90% refund. For example, if you pick up this Java course that you see here before 30th of April, and if you complete 90% or more of this course, you will get 90% refund. That means you got this entire course just for 200 Indian rupees. So it's a very interesting challenge. And personally, I was looking at the DevOps courses that they have. They have AWS Cloud Practitioner related one. And I also went through the course content. It is looking promising. And you are also going to get 90% refund if you complete this within 90 days. So it's an interesting opportunity. If you are looking to buy any of the courses, I would highly recommend checking these courses and grab the 90% off if you are picking any course. Make sure you complete 90% and buy the course before 30th of April. Now let's move to the whiteboard and start understanding our topic for today. Crash loop backoff. Let me explain this in the most simple way. As I've told you in the beginning of this video, crash loop backoff is basically a pod status. That means when you do kubectl get pods, just like how you see the pod status as running, you might see some of your pods with this status called crash loop backoff. But Abhishek, why will you see this status as crash loop backoff? Very simple. As the name suggests, if your pod is crashed and if this happens multiple times again and again in a loop, then Kubernetes will try to tell you using this crash loop backoff the status that your pod is getting crashed multiple times. So this is a pod status that will help you understand that your pod is not in a good shape. It is getting crashed not just once, but again and again in a loop. Let me take a very simple example to explain. Let's say there is a developer in your organization, and this developer is writing a Python Flask application. So the developer has tested the application on his local machine. Everything is working fine. Now developer came to you as a DevOps engineer, asked you to write the Docker file, create a container, and finally deploy this as a pod on the Kubernetes cluster. So what you did is you wrote the Docker file, you took the details required, you wrote the Docker file, then you created a deployment manifest. Then using kubectl apply, you executed this deployment. So the request went to API server. From the API server, scheduler will decide on which node, depending upon your pod. Scheduler will try to identify the node that suits you the best, and scheduler will forward this request to the kubelet on that particular node. Now, what kubelet will try to do, from here it is important to understand the error. So kubelet will try to run your Kubernetes pod. Initially, Kubernetes pod is just nothing but a container and an application, right? Pod has a container, and within the container, you have your application as a running process. So the first thing that happens is your pod will move to container creating status. Because even before the pod goes to the running state, first the container should be created. So always the first status that you will see is container creating. Once the container is created, there are two things that can happen. Either the container and the application inside the container are running seamlessly. In such cases, you will see your pod status as running, or there can be some issue with the container, or there can be some issue with the pod. So you will see the status as error. Again, in both of the cases, like sometimes if the pod status is running, it will run seamlessly throughout its lifetime. But at times, there can also be that your pod gets crashed. For example, your pod initially moved to the running status, and after a while, let's say after 5 seconds, 10 seconds, 1 day, what happened is your pod did not get enough resources that are required. I'm talking about memory resources or the CPU resources. So it got crashed. There can be multiple reasons, but let's say somehow the pod moved to the crashed status. Then what Kubernetes will try to do is Kubernetes will not leave it crashed. It will not just say that, okay, pod got crashed, so it's fine. But what Kubernetes does is it will again try to restart the pod. Because the default policy of Kubernetes out of the box nature is to always restart the pod if it gets crashed or something happens. So it will go back, and again it will start with the container creating status. Sometimes this happens again and again in the loop, and this nature is called as CrashLoopBackOff. But Abhishek, what does this term called as backoff? I'll come back to that in a couple of minutes. But first, I want to make sure this part is clear. So developer asks you to deploy the application. So you created a deployment manifest using kubectl apply. You try to create the deployment. So the request went to the API server. From there, it went to the scheduler. Scheduler decided upon a node. Then it's turn of the kubelet to run your pod. Pod is basically a container and an application that is running inside the container. So your container will initially go to the container your pod will initially go to the container creating status. From there, it can either move to the running status or the error status. In either of the cases, sometimes your pod can get crashed, and when it gets crashed or when something goes wrong with your pod, Kubernetes, because the default nature or the default policy is to always restart, it will restart, and again this entire cycle will start. If this happens in a loop, we call this as CrashLoopBackOff. Now let's come to this part called as backoff. I explained this in the last class as well when we learned about image pull backoff. But if I have to repeat, when Kubernetes tries to restart, What Kubernetes does is first time it will try to restart after 10 seconds. Something happened to your pod. Kubernetes says, okay, I'll wait for 10 seconds and I'll try to restart. Next time, if this happens, instead of Kubernetes taking that action in 10 seconds, what Kubernetes will do is it will increase this delay and it will change it to 20 seconds. So this nature is incremental and next time it becomes 40 seconds. And it has a cap of 5 minutes. So till then, it will increment in this way. And this particular thing is called as back off delay. So from the term called as back off delay, we will just pick this back off, and this particular thing is called as crash loop back off. So the name itself explains it completely, right? Crash loop back off. That means your Kubernetes pod is crashed and this nature is happening again and again. So the pod is getting crashed multiple times. So it's a loop in nature. And Kubernetes is trying to restart it with a back off delay, initially with 10 seconds, then with 20 seconds, then with 40 seconds. So that is how this term crash loop back off came into existence. We will try this with examples, but at the beginning of this video, I said something called crash loop back off does not happen because of one single error, or it does not happen because of one particular thing, but there are multiple reasons why your pod can go to crash loop back off. Why did I say? Because if your pod was initially in the running status or in the error status, let's say running status, there are multiple reasons why your pod can eventually get crashed. Just like your application, right? Your application might be running today, but once exposed to the customer or after a particular time, because of XYZ reasons, application was running initially, it can get crashed. So there are multiple reasons why your application get crashed. Similarly, there are multiple reasons why a running container can get crashed. That's why crash loop back off does not happen because of one single reason. Can you give me some popular use cases? Definitely. We will also try them practically. But if you go to this README file, here I have listed out some 5 common reasons. One is if you do some configuration mistakes, such as you provide an incorrect environment variable for your container, or you are referencing, let's say, a persistent volume that does not exist, or you have something called as liveness probe. We will come to that. And for some reason, your liveness probe is failing, or your readiness probe is failing. Even in such cases, your container will go to the running state, but your liveness probe is failing, so your container will get crashed and it will go to the crash loop back off status. Memory limits are too low. That means, as I have explained, initially your container is running, but later what happened is the memory resources that are allocated to that container are not enough. So it got crashed. Wrong command line arguments. Let's say the command line arguments that you want to pass is Python 3 app.py to just start your application. But instead you forgot or you misconfigured it and you passed Python 3 app1.py. We have example for this as well. Or some errors or exceptions with your application. In any of these cases, your pod can go to crash loop back off. We will try these 3 examples practically on my Kubernetes cluster now. After that, you can also try it by yourself. First, let's start with passing a wrong command line argument. Let me get my terminal. Okay, so I've cloned the same repository, and if you go to the second folder, crash loop back off thing. So we have a simple Python application, right? Assume this Python application is given to us by the developer. And within this simple Python application, we have a file called app.py. This is written by the developer. Just it returns the hello world, nothing much. So what you have done is you wrote the Docker file for it, and you have taken all the requirements that you passed to the Docker file. Unfortunately, when you wrote this Docker file, now in the entry point, you forgot, and instead of app.py, which is the actual application, you provided app1.py. So imagine what would happen. First, when you execute this, your pod will go to the container creating state. Then it will not go to the running state, but it will go to the error state, and the container or the pod will get crashed. Kubernetes will try to restart. Again, it will go to container creating. Again, it will move to the error, and again, it will go to the crash state. Let's see if this happens or not. For that, first, I have to build this Docker file. So I'll just do Docker build. So this is the image. You can use this image directly. I'm building it. Abhishek.F5 crash loop test. Once built, I will push this to the Docker Hub, and I will use the deployment.yaml file and apply that to the Kubernetes cluster. So let's go step by step. Now I will push this to Docker Hub. If you want, you can create this image again. Otherwise, you can also use my image, anything that works for you. So this is the image. Now, what I'll do is if I go back, I already have this deployment manifest called wrong CMD crash loop test. So it's just a simple Kubernetes deployment, right? I just have a deployment. I provided the name, replica is 1. I provided some selector, and in the container section, image, I have provided Abhishek.F5 crash loop test colon v1, which is the one that we just created. Now let's try kubectl apply -f. First, let's see if my cluster is up or running. Okay, minikube status, cluster is running, and let's see if there are any deployments. Let me delete this. Kubectl delete deploy crash loop example. Okay, now I don't have anything. So let me do kubectl apply. Okay, let's see what we have learned and what we are trying practically are same or not. So for that, I have to do kubectl get pods and watch the status. Okay, it already went into CrashLoopBackOff because we took some time, but we will see that happening because this is a loop, right? So again, the pod went into the error status. Initially, it started with container creating. Then by the time we saw, it actually got crashed. But we can see that loop happening. CrashLoopBackOff. Then it went to the error state. Again, it went to the CrashLoopBackOff. So let's see if this happens again and if it goes to the error state. Perfect. Again, we saw the status as error. You can also delete this and try one more time. There will not be any difference, right? If we do it again, kubectl apply -f, and this time immediately I will do kubectl get pods. So we can see container creating, error, and CrashLoopBackOff. Exactly what we learned, right? Container creating, error, it got crashed. Then it tried to restart. Because this is happening, the status is CrashLoopBackOff. Perfect. So this is how CrashLoopBackOff works in one of the cases. We just saw one example. We can also fix it. It's very simple. To fix it, we will just go to the simple Python application, open the Docker file, change the app.py, and let's build this. This time, what I'm going to do is I will change the version from V1 to V2. So V1 is the crash loop backoff error image, and V2 is the actual one where we have fixed it. So this time it has to work. Let's see. So again, I will do docker push, and I'll try to push V2. Once this is done, we will go to our deployment file. We will use the same one, but we will just change the image from V1 to V2. Okay, now let's run kubectl apply -f, and the container which was in the error status, now it has to automatically change and move to the running state. Let's see. Okay, crash loop backoff took place 4 times. Then the new one is getting created and the new one is running. What about this one? This is the previous pod that is getting terminated, right? Now the new one that we have is in the running status. Let's see if that is true or not. kubectl get pods. So we have our new pod which is in the running status. So we have fixed this error. The error was very simple, where the command line argument or the CMD of the Docker file was provided wrong. Let's make things little more complicated, and let's move to the next example where we will play with the liveness probe. So I'm going to use the same image because I've built the image. I'm using this Docker file, the same thing. I will use the same application. So Abhishek F5 crash loop test V2. But this time, what I'm going to do to my deployment file, till here it's the same. I've added a new field called liveness probe. What is liveness probe? If you don't know what is liveness probe, let me explain. There are 2 probes in Kubernetes which are popular. Actually, there are 3. There is something called startup probe as well. But the popular ones are liveness probe and readiness probe. And in this example, I'm going to use liveness probe, which is similar to the load balancer concept. If you know the load balancer concept, how does a load balancer understand if the targets where it has to forward the request are healthy or not? So what a load balancer does, let's say if this is VM1 and if this is virtual machine 2. So load balancer will continuously check the health of virtual machine 1. Only if the health is good. When the user tries to send a request to the load balancer, if virtual machine 1 is healthy, it will forward the request to virtual machine 1. If both of the virtual machines are healthy, what a load balancer will do, depending upon the algorithm that you have chosen. If you have chosen random as the algorithm, 1 request it will send here, 1 request it will send here. 3rd request will go here, 4th request will go here. But imagine if the load balancer does not have the concept of checking the health of your virtual machine. Customer sends a request. First request will go here, it will fail. Second request will go here, it will pass. Third request will fail. Fourth request will pass. This is not the right way how your load balancer should be. So every load balancer has a way of checking the health of its targets. Similarly, even in Kubernetes, kubelet has a way of verifying if the pod is always healthy or not. How can kubelet identify if your pod is healthy or not? If you configure something called as liveness probe, kubelet will understand if the liveness probe is passing, then kubelet will understand that, okay, the pod is in the healthy status. If the liveness probe is failing, what kubelet will do is it will immediately restart, right? If the liveness probe is failing, kubelet will immediately try to restart your pod, because if it does not restart, again, like I explained here, this pod might receive a request from the customer and the pod is hung or the application is hung, it is not working, it is not responsive. So customer will not receive any response. To avoid that, it is ideal to configure a liveness probe for your pod, which acts as a health check. And who is checking this health? Kubelet will check. How will kubelet check? You can provide a script or you can provide some parameters within your liveness probe using which kubelet will understand if the pod is healthy or not. If the pod is not healthy, kubelet will always try to restart, right? So that's what I did here. To this particular deployment, I have passed a liveness probe, and in the liveness probe, I said, kubelet, just try to check this file. And in this file, I will tell you if the pod is healthy or not, which does not even exist. So this liveness probe will always fail. And when this fail, kubelet will try to restart. When it restarts, again it will fail. So I am intentionally creating this state of CrashLoopBackOff just to demonstrate you that CrashLoopBackOff will also happen if your liveness probe or readiness probe will fail. Okay, let's try to do this. So first, let me delete the deployment. Cool. I don't have anything on my Kubernetes cluster. So now I will try to execute this. kubectl apply -f. This time the status will be, if we go back to our diagram, first we will see container creating. Then we will see container will move to the running status. After it goes to the running status, let's say after 5 seconds, it depends on what you have configured. I have configured as 5 seconds. So after 5 seconds, liveness probe will trigger. Liveness probe will fail. So kubelet will restart your container. So it will again go to container creating. Again, it will go to running. This will repeat again and again and again. So your pod will eventually go to the CrashLoopBackOff. Let's see that. Okay. kubectl get pods -w. So first we saw the running status. By the time we executed this, it moved from container creating to running status. That's fine. But now from the running status, after a particular delay, which is, I have provided period seconds as 1. That is, after 1 second, kubelet will try to verify if the health check is passing or not. If it does not pass, then it will try to restart the container. So it restarted once. See, you can clearly see here, restarts 1 time. Now it will wait for 10 seconds. And after 10 seconds, because as I've told you, in the CrashLoopBackOff, what Kubernetes does is it will create a delay of 10 seconds. After that, it will again try to restart the container. And once it is started, after 1 second, it will try to execute the liveness probe. Let's see if that happens. Okay. Again, it restarted. Second time. Now it wait for, let's say 20 seconds or 30 seconds. After that, it will again try to execute the liveness probe. So this will happen, and eventually you will see the pod status as CrashLoopBackOff. Let's wait for it. Okay, you can see the status as CrashLoopBackOff. Now you might say, but Abhishek, you created or you simulated this behavior by providing the wrong liveness probe. But how does that work in the real environment? In the real environment, you will not create this liveness probe. You can get it from the developer, because usually in the liveness probe, you will see something like HTTP get, and you will put the API which kubelet has to hit, something like maybe /health. So the application that developer gave you, it will have this context path, or it will have the API called /health. And when the kubelet tries to hit this one, kubelet will receive the response as 200, or it will receive the response as 500. Depending upon the response, kubelet will understand if it has to restart the pod or not. So because I'm using a very simple application, I don't have the /health endpoint. So I just simulated this behavior where the liveness probe will fail. But in your organization, when you're working, the liveness probe might fail because the API returned 500, 404, or whatever, which made kubelet to restart the pod. Okay. Similarly, readiness probe as well. When it comes to readiness probe is basically used to check if your pod is ready to receive the traffic or not. Liveness probe is basically used to check if your pod is healthy or not, if your pod is live or not. But readiness probe is basically used to check if your pod is ready to receive the traffic or not. Okay. So we will get to readiness probe some other time because it is not the context of the discussion today. Cool. So we learned another example. Now we will go to the final one, which is very, very common in the world of Kubernetes. And this is the most common reason for CrashLoopBackOff. Let me delete this. So what I have done, I have removed the liveness probe and I have introduced a new section to the deployment, which will again create the CrashLoopBackOff. This section is the resources section. Very, very important if you are working in an organization. What happens is you have one Kubernetes cluster, right? So if I let me take a new one. So you have a single Kubernetes cluster that you are managing between multiple teams. So as a DevOps engineer, how do you manage is, now I'll explain this in more detail again, but today what I want to explain is when you have a Kubernetes cluster and when there are multiple namespaces, let's say there are 5 namespaces, and each namespace is used by a different project. So this is namespace A used by project A, project B, project C, project D, and project E. So Kubernetes cluster is combination of nodes. Let's say you have 3 nodes, and 3 nodes together has, for example, 60 CPUs and maybe something like 64 GB RAM. All together, all 3 nodes together just have 64 GB RAM and 60 CPUs. Now, if you are running pods, so namespace A is running 5 pods. So they have pod 1, pod 2, pod 3, pod 4, and pod 5. Assume you did not provide any limitations to the resources that pod can consume. What if namespace A, the 5 pods, is consuming entire 60 CPU and 64 GB RAM? Then although B, C, D, and E, they also have the namespaces on the clusters, but when they try to schedule their pods, these pods will not be able to schedule. They will not run on the clusters because namespace A itself ate all the resources of the cluster, or one pod of the namespace A is eating away all the resources of your Kubernetes cluster. It can be because this particular pod is leaking memory. It has some issue which makes it consume a lot of memory. But as a DevOps engineer, it is your responsibility to distribute the resources of your Kubernetes cluster between the namespaces as well as between the pods. So for that, what you will do is at the namespace level, don't worry, I will explain this concept again going ahead because we are going to do some practicals on this kind of thing as well, the troubleshooting. But at a high level, understand that for namespaces, you will configure resource quota, and for the pods, you will create requests and limits, just like how I did for this pod. So for this pod, I said limits as CPU memory. So CPU, I just provided like not even 0.25% of a CPU. This is 0.05, 0.025% of CPU. So if I provide 1000 here, that means one CPU. So I've just provided 25, which is 1/40th of a CPU. So intentionally, I've provided very less resources because I want this pod to start and then I want it to be crashed. So initially, when the pod is starting, application does not need resources. So it will start. Then once it starts using the resources from the cluster, I have limited it, right? So what happens is this 1/40th of CPU will not be sufficient, so it will crash. Or 1/40th of 1 GB memory is not sufficient, so it will crash. Let's see if that happens or not. So kubectl apply -f 03. So let's quickly do kubectl get pods container creating. Now it should go to the running state and immediately it should again crash because see, it went to the running state and now it should crash because I've provided very less resources intentionally. Now in your organization, you might not put this much less resources, but the applications might leak. For example, here you have provided one CPU. You deliberately provided one CPU for that particular pod because you want to restrict the pods to consume less resources. So you spoke to the application developer. Application developer said, yeah, this pod should not take more than one CPU. So you have granted it one CPU. But what happened is that application is not behaving properly and it is leaking CPU, it is leaking memory. And because of that, it ideally has to consume less than 1 GB RAM, but it started consuming more than 1 GB RAM. So it is a behavior that developer has to fix. You will report to the developer that, okay, the container is running, but eventually it moved to the CrashLoopBackOff. So you should do something with the application. It is consuming more memory than what you have committed. So I'm creating an issue for you, right? We can see it. It will take some time. Let's wait. Perfect. You see this error? OOMKilled. That is, your container failed with an error or it crashed with an error called out of memory. This is a very common error in the world of Kubernetes, out of memory. So when you receive this out of memory error, that means either the resources that you have provided for your pod are not enough, or the pod is taking more resources than it should actually take. In any of the cases, you will ask the developer, what is wrong with it? You said it only will take 1 GB RAM, but when I see this, it returned the error out of the memory killed. That means sometimes it is consuming more than 1 GB RAM. So developer, how will you address it? Do you want any logs of the application? If you want logs, give the logs. If you want thread dump, give the thread dump. And it is up to the developer to go back and fix this out of the memory killed. When this repeats, you will see the pod will go to CrashLoopBackOff. Let's just wait for 20-30 seconds and you will see that error. Perfect. See, OOMKilled, then it went to running. Again, it went to OOMKilled. Then you started receiving CrashLoopBackOff. Exactly what we learned, right? Container creating, then it went to running status. Container creating, running status. Then here it got crashed. Why it got crashed? Because of OOMKilled. Previously, why it got crashed? Because the liveness probe failed. Before that, why it got crashed? Because the example that we have taken here, right? Once out of memory, once liveness probe, and once we have provided wrong command argument. So I've shown you three different ways of why a pod can get crashed. There are multiple ways, but in this case, it is getting crashed because of OOM killed. So finally, your application went into crash loop back off state. This will repeat and you can try it out. Trust me, it takes a lot of time to create these examples because I have to test it. I have to make sure the Python application is getting crashed. Here, I have to make sure the liveness probe is crashed. I have to provide some wrong command arguments and try. So there is a lot of effort that goes into it. While I'm recording this video, it's almost like 3 a.m. So all that I want to say is it's okay. Just try to do these things on your own. Initially, if you can't get it, try it one more time. Try to watch the video again. If you need some help from the documentation, you can refer to the documentation here or from the Kubernetes official docs. But Kubernetes troubleshooting is very, very important. Even for me, I did not learn all of these things at once. It took a lot of time for me. I've been working on Kubernetes from last 6 to 7 years. So this will come eventually, but you have a mentor at this point of time. You have so many docs, you have so much resources. So please try to execute the things at your end and let me know in the comment section, how did you find this video? Let me also know what are the future videos that you are expecting in this series. Let's see if your guesses are right. Thank you so much. See you all in the next video. Take care. Bye bye.